Hello, I'm going to introduce section 3.8 Hyperbolic Functions. First, I'll start off by describing what are hyperbolic functions. It can be basically written down into two basic equations. Hyperbolic cosine of x equals to e to the power of x plus e to the power of negative x over 2. And hyperbolic sine of x equals to e to the power of x minus e to the power of negative x over 2. So how can I graph those two equations? First off, we have to write two separated equations from the original hyperbolic cosine of x equation, so that we separate that into these two equations. One is y equals half e to the power of negative x, and so another is y equals half e to the power of x. So then what we do is we draw a graph followed by the guidelines. So then we can get hyperbolic cosine of x. Same thing for the hyperbolic sine of x. First, we have to draw two different equations. First is y equals 1 half e to the power of x. The second is y equals negative half e to the power of negative x. So with the two guidelines, now I can draw hyperbolic sine of x as following. There are two interesting facts about hyperbolic cosine of x and hyperbolic sine of x. Let me look at when x equals 0 here and this point. On the hyperbolic cosine of x, when x equals 0, y equals to 1. On the hyperbolic sine of x, when x equals 0, hyperbolic sine of x equals also 0. What can I conclude with this is that if you recall the trigonometric functions of cosine and sine x, the cosine of 0 was 1 and sine of 0 was 0. So on the hyperbolic functions, the basic identities of trigonometric functions still holds. Another point that I can focus on is 1. The hyperbolic cosine of x is an even function, and 2, the hyperbolic sine of x is a odd function. So with those properties, we can write it as hyperbolic cosine of 0 equals 1 and hyperbolic sine of 0 equals 0. And for the even and odd functions, we can write down as hyperbolic cosine of negative x equals to hyperbolic cosine of x, and hyperbolic sine of negative x equals to negative hyperbolic sine of x. To move on, the hyperbolic tangent. What do you recall about the tangent? It is sine x over cosine x, right? So what will be the hyperbolic tangent? It is basically the same thing. Hyperbolic tangent of x equals to hyperbolic sine of x over hyperbolic cosine of x, which is e to the power of x minus e to the power of negative x over e to the power of x plus e to the power of negative x. So far in chapter 3 we did several derivations, and then now it is time for the derivatives of hyperbolic functions. The most important thing while getting the derivations of hyperbolic functions is that if you recall that the two equations of the hyperbolic cosine of x and hyperbolic sine of x, they're usually associated with e to the power x or e to the power negative x or vice versa. So what we use, the most important derivation that we know already is d over dx equals e to the power of x equals the e to the power of x. By using this, we can get basically the derivations of the hyperbolic functions. For the hyperbolic cosine of x, the derivation will be If I put 1/2 as constant, pull it out, and then now I have only this part is a plus of the derivation, so I can separate it. So their results will be e to the power of x minus, since it is a chain rule, e to the negative x. And the constants come here over 2. What can you recognize by looking at this is that this equation is the hyperbolic sine of x. So we can conclude that derivation of hyperbolic cosine of x equals to hyperbolic sine of x. Similarly, we can do with the hyperbolic derivation of hyperbolic sine of x, so that we can get the result of hyperbolic sine of x equals to hyperbolic cosine of x. So here is the point where the trigonometric function and the hyperbolic functions are different. That the derivation of cosine of x was minus sine of x, if you recall it. But here, derivation of hyperbolic cosine of x equals to positive hyperbolic sine of x. Let me give you some examples of the derivations. So how can we get the derivation of sine hyperbolic sine of 3z plus 5? We basically use the chain rule. d over dx of hyperbolic sine h of 3z plus 5 equals 3 times, because here goes the chain rule, times hyperbolic cosine, as we did, of 3z plus 5. So that it is 3 hyperbolic cosine of 3z plus 5. Let me go on to the next example. How can we find hyperbolic cosine squared t? The most explicit way of calculating the derivation is by using the product rule. We separate the hyperbolic cosine into two hyperbolic cosines, and by using the production rule, we can have d dx of cos t times cos t plus cos t times d dx of cos t, so that we can get sinh t times cos t plus cos t times sinh t. This equals to 2 times sinh t times cos t. If you remember the double angle formula, we can rewrite this into sinh of 2t. If you recognize that I pronounced hyperbolic cosine of t and hyperbolic sine of t as cos t and sinh t, it is okay, because many people use these pronunciations to simplify hyperbolic sine of t or hyperbolic cosine of t. The last example that I can give you is g theta. Why can we get the derivation of g theta of ln of cos of 1 plus theta? Again, this is the chain rule. It seems a bit complicated, however, it is at the end, the result is super explicit and simple. So d dx of g theta equals 1 over cos h of 1 plus theta times sinh of 1 plus theta. If you can see, ln of d dx of ln x is 1 over x. So 1 over this whole thing goes into here on the denominator. And then here we have to use chain rule, this section, chain rule, to again multiply in here, so that we can get sinh 1 plus theta. So that as the result, what we can get is tangent of 1 plus theta. This was it. If you have any questions, ask me or ask Miss Riggins about further questions, and then good luck on your finals. Thank you.